Okay, in this lesson we're going to solve two different kinds of equations. We're going to solve radical equations and then we're going to solve quadratic equations. Okay, solving equations relies on the idea of undoing a statement already done or doing the opposite, okay? So, what does that mean? Well, you do this all the time in solving equations. If you have a plus, you undo that addition with a subtraction, or if you have a subtraction, you undo it with an addition. If you have a multiplication, you undo it with what? A division, right? Okay, so this is what we're going to do. If we have a square root, you're going to undo that square root with an exponent of 2. If you have a cubed root, you're going to undo that cubed root with an exponent of 3. In other words, whatever your index is what the exponent is that undoes that. And the same thing, if you have an exponent of 3, you'll undo it with a cubed root. Okay, so to undo a square root, you will have to square both sides. In other words, you're doing the opposite action. Okay? So, let's look at this. The square root of x equal to 4. Undo that square root by squaring both sides. So this undoes your square root, leaving you with x is equal to 4 times 4, which is 16. Okay? Now, there are a couple questions we can ask ourselves to facilitate this whole thing. The first question is the radical isolated? Because you cannot undo it until it is isolated. And remember, when you had a radical and it was equal to a negative number, this wasn't possible either, because unless I have a negative sign in front, the principal root of a radical square root is positive. If you have a square root equal to a negative, it is not possible. So is the radical isolated? And then the second question you'll ask yourself is it possible? And if you remember these questions, it will help you to avoid a lot of mistakes. And is it possible in the real numbers? The next lesson we do, or the last one, we'll look at non-real numbers in the real number system. Okay, because you don't have any other system at this point in time. So let's look at some examples of solving these. I'm going to leave those two questions up here because we're going to use them over and over. So, example, x minus 3, it's all under the radical, equal to 6. So, is this radical isolated? Yes. There's nothing outside the square root multiplying or outside the square root adding or subtracting from it. So it is isolated. Our second question is it possible? Yes, because this radical is equal to a 0 or a greater than or equal to 0. So we're good to go. So we're going to undo it by squaring both sides. That undoes that, leaving you with x minus 3 is equal to 36. Now continue solving your equation, and I end up with x is equal to 39. And remember, you can always put it back in and check it. 39 minus 3 is 36, and the square root of 36 is 6. So you know it's possible. Let's look at another one. Square root 6x plus 22 equal to 2. Okay? First question, is the radical isolated? Yes, it is. Nothing multiplying it or adding or subtracting from it. Now, it's equal to 2. Is that positive? Greater than or equal to 0? Yes, so it's possible. So undo it by squaring both sides, and I end up with 6x plus 22 is equal to 2 times 2, which is 4. Subtract by 22 from both sides, and I end up with 6x is equal to negative 18 divided by 6, and x is equal to a negative 3. Okay? A lot of times this kind of throws you. You got a negative. How can a negative go underneath the square root? Well, find out. Let's check it. 6 times negative 3 plus 22, that is equal to negative 18 plus 22 is 4. See, now it's positive, and that's equal to 2. So you see, it does work. It really does. Okay, let's look at another example. Square root x minus 9 plus 8 is equal to 0. Okay. First thing we see here is my radical is not isolated because it has a plus 8 outside. So the first thing we have to do is isolate it. So we're going to subtract 8 from both sides, and I end up with the square root of x minus 9 equal to a negative 8. What is the problem here? Well, this produces a positive number, and I have a negative here. Therefore, this is not possible in the real number system. It's not possible. Therefore, this has no solution. And you can also use this symbol here to mean no solution. Okay, let's look at another example. 32 minus 2 times square root 2x plus 6 equal to 0. Okay. First step. Is it isolated? Well, obviously not, because I have this and this, which are both outside. So the first thing I'm going to do, instead of divided by 2, which would require everything to be divided by 2, we're going to subtract our 32 from both sides. And that's going to give me negative 2 times 2x plus 6 inside equal to a negative 32. Now, divide by your negative 2. And that eliminates that, leaving you with your 2x plus 6 equal to positive 16. Now, is the radical isolated? Yes, it is. Is it possible? Yes, it is, because this is greater than or equal to 0. So now, you're going to undo your radical by squaring both sides. 2x plus 6 is equal to 256. Now subtract your 6, and I get 2x is equal to 250 divided by 2, and x is equal to 125. Okay, now we're going to move into much more complex ones. And when we move into this, it's not going to be quite as clear cut as it has been. So let's look at examples where you have a radical equal to a radical. So square root of 3y plus 6 is equal to the square root of 2y plus 7. Since everything is inside the radical, all you have to do is square both sides. That eliminates all the radicals, and you end up with 3y plus 6 is equal to 2y plus 7. Subtract your 2y, and I end up with y plus 6 is equal to 7. Subtract your 6, and y is equal to 1. Okay, and it is a valid answer. If we put our 1 back in, we'd have 3 times 1 plus 6. Is that equal to 2 times 1 plus 7? Well, 3 plus 6 is the square root of 9. 2 plus 7 is square root of 9. Square root of 9 is 3 is equal to 3. So as you can see, we can check it pretty easy and tell if it's valid or not. Okay, let's move on. Square root x squared plus 3x minus 8 is equal to x. Okay, your square root is isolated, but this is very different because you don't have a number over here, you have an x. But the same principle applies. Our square root is isolated, and it's possible as long as that x is greater than or equal to 0. So let's go ahead and square both sides. This undoes that, leaving you with x squared plus 3x minus 8 is equal to x squared. Well, what happens when we subtract x squared from both sides? Those disappear, and you're left with 3x minus 8 is equal to 0. Add your 8 to both sides, and 3x is equal to 8 divided by 3, and x is equal to 8/3. Now, we could put this in and we can check it. So let's go ahead and check this one, because it's a little bit kind of hairy otherwise. Okay, 8/3 squared plus 3 times 8/3 minus 8. Is that going to equal 8/3? Question mark. Well, this cancels with that, leaving you 8/3 squared, square root of that, plus 8 minus 8, that's 0. So the square root of 8/3 squared, these undo each other, and that's equal to 8/3. So as you can see, it really does work out. You have to check them though when you're squaring things. Let's look at another one. Now as you can see, we're combining things that are very different from what you did in Math 100. This is the next step up. You're now looking at things with squares in it. You're looking at things with one side having variables that are not squared, or in the radical other side having it. So let's look at this. Square root 6x plus 7 equal to x plus 2. Okay? Again, my square root is isolated. Since it is isolated, we can undo our square root by squaring, but when we square this is going to have to be FOILed. In other words, this is equal to x plus 2 times x plus 2. Okay, keep that in mind. So this undoes this, giving me 6x plus 7 equal to, well, x times x is x squared, plus 2x plus 2x is 4x, and then 2 times 2 is 4, okay? Now, we have to turn this into 0 on one side because we have a square. So, minus 6x minus 7, minus 7. So this side is now going to be 0, and I'm going to flip it. So I have x squared minus 2x minus 3 is equal to 0. Now we can factor this. X minus 3 times x plus 1. Negative 3x plus 1x gives you negative 2x, so we have it factored correctly. See, here's your negative 3x, your 1x, add these together, negative 2x, which gives you this, negative 3 times 1 is negative 3. So we've got it factored correctly. Now, this whole thing is equal to 0. Therefore, x minus 3 equals 0, and x plus 1 equals 0. So x is going to equal 3, and x is equal to a negative 1. But because we squared up there, we have to check these answers. There may be one of them that's not valid, so let's check it by putting it back into the original. So, square root 6 times 3 plus 7. Does that equal 3 plus 2? So square root 18 plus 7, and 3 plus 2 is 5. 18 plus 7 is 25. That equals 5. So yes, this one is valid. Now let's try the negative 1. 6 times negative 1 plus 7. Does that equal negative 1 plus 2? Well, negative 1 plus 2 is 1. Negative 6 plus 7 is 1. So the square root of 1, that does equal 1. So 1 equals 1. That one is also valid. You see how you have to check both of them to check and see if they're valid. Okay. Let's look at one more of these at least. Now this one's going to go back to having to isolate your square root. Okay, so let's look at this. Square root of x squared plus 9x plus 15 minus x minus 4 equals 0. Now remember the first question, is your radical isolated? This one, it is not isolated. So the first thing you're going to have to do is eliminate this stuff here. So we're going to add x and add 4 to both sides. That becomes 0. This becomes 0. And you're left with square root of x squared plus 9x plus 15 is equal to x plus 4. Now just like in the last problem, now it's isolated and it's possible, because I don't have a negative number over here, I'm going to square both sides. And again, this is going to require you to actually do this polynomial multiplication, which will require foiling. So this is going to equal x squared plus 4x plus 4x is 8x, and 4 times 4 is 16, and this undoes that, leaving x squared plus 9x plus 15. Look what happens when you try to move it all to one side. Let's start with that x squared. That's canceled, that's canceled. So we don't want to continue on since our x squareds are left. So 9x plus 15 is equal to 8x plus 16. Subtract my 8x from both sides. And this is going to give me x plus 15 is equal to 16. Subtract that 15 from both sides. And we end up with x is equal to 1. And again, we have to check and see if it's valid. So let's put it back in. 1 squared plus 9 times 1 plus 15 minus x minus 4. Does that equal 0? Oh, minus 1 minus 4. So this is the square root of 1 plus 9 plus 15. 10 plus 15 is 25. Minus 5, does that equal 0? This is minus 5. Square root of 25 is 5. 5 minus 5 equals 0. So yes, it is valid because they are in agreement. Okay, what do we have time-wise? Any more of these? Yeah, let's go ahead and stop.